Local AI stacks meet reality. Two very different local AI build philosophies collided this week. Multi-GPU boxes versus compact APU rigs. In a widely watched thread, practitioners compared a dual RTX 3080 20GB setup on an E2 server motherboard against an AMD Ryzen AI-based GMK Evo X2. The consensus for image video generation in mid-sized dense LLMs was blunt. VRAM and GPU bandwidth win. Reported numbers for Qwen 332B on comparable rigs were 800 to 900 tokens press prefill and 25 to 30 T per second decode with llama.cpp, and roughly 500 T per second prefill and 40 T-seconds decode via VLLM on earlier AWQ variants. Quantized 30B models even hit 100 T per second decode on 3080 20GB cards. Meanwhile, attempts to stretch into 120B either need more GPUs or accept steep offload penalties. DDR4 bandwidth and limited memory channels hamper MoE performance. The quiet benefits of the GMK, lower power, less noise, are real, but so are reports of ROCm instability in Comfy UI and a persistently slow VAE stage versus NVIDIA. A few commenters defended AMD's stability, but the shared lesson stands. For models that fit in VRAM, GPUs dominate. For those that don't, throughput tanks on system RAM offload no matter the CPU's theoretical bandwidth. Caveat emptor on used cards and motherboards too. Kernel maturity also changed the leaderboard in a surprising place: multimodal inference. On NVIDIA's new Blackwell workstation cards, SM12.0, Qwen 3VL32B quantized to Q8 in llama.cpp, outpaced VLLM's FP8 path for single requests with limited context. The reason is prosaic, not magic quantization. But kernel selection. VLLM's FP8 uses Triton on SM12.0, and only FP8 block currently routes to optimized CutLAS. Without tensor parallelism TP and batching, llama.cpp's hand-tuned path wins on a single card. The posted Q8 numbers 64 TS prompt prefill and 37.5 tech decode are a reminder to match engine precision and hardware. VLLM still shines with batching TP and long contexts. Llama.cpp is a powerhouse for single-stream, single GPU responsiveness. One more gotcha for vision tasks: works on spaces, fails locally. Several OCR stacks that produced crisp results in Hugging Face demos devolved into hallucinations on local runs, until the backend was swapped. Miner U 2.5 performed on par with the hosted demo only after switching from the pipeline backend to VLM transformers, which manages precision casting differently. That pattern matched reports for other OCR models, plus the perennial CUDA dependency skirmishes. One user was pinned to CUDA 12.8 on a 5090 and contemplated adding a 3090 solely for older CUDA compatibility. The moral isn't new, but it matters. Hosted demos often run different backends, precisions, and batch defaults than your machine. Replicate those choices before you judge a model. Efficient diffusion on AMD GPUs. AMD published a concrete counterpoint to "You need monster GPUs for good T2I," a small, fast, open model family. Nitro E is a 304M parameter diffusion transformer trained from scratch in 1.5 days on a single node with 8 Instinct MI300X GPUs. On inference, it pushes 18.8 images spats batch 32 on 1 300X. A distilled variant doubles that to 39.3 images secs, and a JRPO-tuned version targets prompt adherence. The efficiency comes from aggressive token reduction. A compressive visual tokenizer, a multipath compression module, reinforced positional cues, alternating subregion attention to localized compute, and a lightweight ADAL-N-affine for modulation. The code and technical blog are open, with 20-step and 4-step pipelines ready to run. That release lands alongside mixed field reports on AMD's desktop stack. Some GMK Evo X2 owners praise low wattage and quiet operation, noting text inference is really good. With today's software, while others document repeated ROCm crashes in Comfy UI, illegal memory access, HIP failures across ROP 6.3 to 7.1. Even on successful runs, users still flag the VAE stage as notably slower on AMD than NVIDIA for image generation. An area Nitro E's end-to-end efficiency may offset on Instinct parts, but not necessarily on consumer APUs today. Progress is clear on AMD's data center gear. The desktop story remains uneven across use cases and drivers. Kernel-level details matter here as well. The Qwen 3VL comparison above hinged on FP8 kernel choices for new NVIDIA architectures. Similar, small hinges swing big doors issues exist across vendor stacks. Before declaring winners, scrutinize precision, kernels, and batching modes, not just model names and headline numbers. RAG UX context engineering. Enterprises trying to replace Zapier-hosted chat agents with on-prem RAG want more than a model. They want a web UI that non-developers can administer. One team outlined a pragmatic wish list, named knowledge bases, URL and Google Drive scraping, scheduled rescrapes, and the ability to route a chat request to selected bases via Alama. The closest open option proposed was an API-first RAG service, TLDW server, with scheduled import scraping, tagging, multi-user, multi-database support, and a fancy chunking library, though no GUI yet. A browser plugin is in the works, and the stable API surface allows teams to build their own admin UI now. It's a realistic snapshot. The plumbing exists, but the last-mile UX for business users still takes work. On the front end, some teams are reassessing Open Web UI after recent licensing changes and are seeking lightweight OSS chat GPT-like clients with API CLI support. There's a growing menu of alternatives, and connecting to local backends remains straightforward. Llama.cpp's Llama server exposes an OpenAI-compatible HTTP API that tools like Open Web UI can hit directly. The driver is control, consistency, and cost, not novelty. The deeper shift, however, is moving beyond prompt engineering into context engineering, the design, orchestration, and optimization of everything an LLM sees at inference. A new handbook frames context as the complete information payload: exemplars, retrieved passages, tool specs, memory, state, and control flow. It synthesizes insights from some 1,400 papers and recent conference work into a practical curriculum. The point isn't semantics, it's reliability and efficiency. Better design context, reduce confusion, cut token waste, and make system behavior auditable, especially critical as organizations formalize governance. That same context is everything lens also explains why specialized extractors are getting traction. Liquid AI's 1.2b parameter LFM2 extract is trained to return structured JSON XML YAML from unstructured text across 9 languages, with guidance to use greedy decoding, temperature, and single-turn chats. Their reported evaluation spans syntax validity, format compliance, keyword faithfulness, and LLM judge scores, and they claim performance above Gemma 327b on extraction despite the huge size gap. Right or wrong on the leaderboard, a small deterministic extractor that parses cleanly is a practical RAG component and cheaper to run. Agents, from indie builds to swarms. Agent building is stretching from scrappy to scaled. On the scrappy side, a student shared progress on a VTuber-style character driven by Alama, an end-to-end hobby build in Python that blends LLM control with persona and visuals. It's rough-edged by design and emblematic of how far local tooling has come. Anyone can assemble a believable AI on stage with commodity parts. On the scaled with receipts side, an independent builder replicated the workflow behind a widely discussed 40-cul-month PDF to Excel bank statement service with a general agent, read statements from storage, extract transactions and metadata, format a styled multi-sheet Excel, generate charts and insights, and email the result. The claim is it can process thousands to tens of thousands of documents without hitting context limits by relying on storage and task decomposition, not chat history. The whole thing ran from a single high-level instruction, with analyst prompts split out. It's a sober demonstration of where agents are actually paying off today. Well-scoped, automatable back-office tasks. Orchestration is maturing too. Agentic Flow v1.9 introduces a self-learning optimizer that studies every run and adapts routing topologies, hierarchical for heavy builds, mesh for collaboration, ring for staged processing, without manual tuning. A new federation hub spins up disposable agents in milliseconds, tears them down cleanly, and supports hundreds or thousands of concurrent workers. Supabase integration provides real-time, shared memory with full traceability. It's not the flashy AGI of marketing decks, but the hard part that makes agents reliable, observable, and cheap. Long context and GUI agent research. Long context is colliding with multimodality in inventive ways. Glyph proposes a detour around token limits by rendering long text into images and feeding those into a vision language model, VLM. By compressing tokens into pixels, Glyph reports 3/4 times input compression at 96 dpi, 2-3 TEMs at 72 DPI with competitive performance on long bench MRCR and faster prefill on 128K token inputs relative to the text backbone. It supports VLLM acceleration and includes a demo for side-by-side comparisons. The caveats are crucial. Performance is sensitive to rendering parameters, font spacing, rare alphanumeric strings remain hard, and generalization beyond long context understanding is unproven. Still, it's an intriguing trade. Buy efficiency with vision. Meanwhile, a new RxEve paper argues that GUI agent's 60% ceiling on the Android control benchmark is an artifact of benchmark flaws, not a fundamental limit. Android control purifies tasks, fixing flaky labels and platform issues, and shows substantially higher success rates with the same agents. If the critique holds, it reframes progress. We may be underestimating current agents due to test harness noise. Cleaner benchmarks won't make agents smarter, but they will make comparisons honest and investments smarter. The performance engineering angle from earlier resurfaces here. Engine, kernel, and batching decisions change outcomes as much as architectures do. Whether compressing context into pixels or shaving milliseconds off prefill with the right kernel, the how matters as much as the what. DevSec, IDE supply chains, permissions, E2E. A live supply chain campaign is targeting AI coding agents via malicious VS Code-compatible extensions in the OpenVSX marketplace. A recent fake Solidity extension, Wanyonko.solidity_vlang, still shows 5 stars while behaving like a remote access Trojan. It triggers on opening .sol files, drops a lock file, spoofs a function call to launch the rat, fingerprints the machine, and pulls Sleepy Duck. XYZ every 30 seconds, falling back to an Ethereum contract to fetch new C2 if the domain is down. The warning is broader than one package. AI coding assistants extend your attack surface to IDE extensions, model context product servers, and even rules pasted into the IDE. Treat them as perimeters. Practical hardening exists. In Claude Code, approvals for MCP tools can be whitelisted per server in Claude/settings.json at the repo or user level, eliminating repetitive prompts while limiting blast radius. A community-shared config enumerates Chrome DevTools MCP methods alongside default tools in an allow list, leaving deny and ask empty for that server. It's not perfect segregation, but it reduces clicks and errors and keeps least privilege explicit. On the data path, simple secure building blocks help. The share tool provides end-to-end encrypted file transfers via a lightweight WebSocket relay that never sees plaintext. Keys are established with ECDH-P56, data is wrapped in AES-GCM, transfers include chunkacks, retries, reordering, stall aborts, and SHA-256 integrity checks. It runs via web or CLI and can be self-hosted. For teams wiring agents and LLMs into workflows, this kind of dumb but safe transport avoids accidental data exposure. Underpinning all of this, the hypervisor layer remains quietly strategic. Floss Weekly's latest deep dive on Zen highlights why it shows up in IoT and automotive, a small, battle-tested isolation substrate that runs almost everywhere. Security starts with what you share a box with. Clean virtualization is still the first moat. Edge self-hosting and monitoring. The run-it-yourself ethos extends beyond models to ops. OpenStatus added private monitoring locations deployable on a Raspberry Pi with a tiny Docker image, small enough to run on a 1 gigabit RAM Pi 3 from 2016. You provision a token, run the container, and it pulls assigned checks, auto-refreshing its config every few minutes. Results stream to a central ingest for aggregation. It's a cheap way to monitor internal apps, measure real-world latency, Office Home, or sprinkle probes across sites like farms or factories, useful for anyone hosting LLMs or RAG services behind firewalls. That kind of edge deployment mirrors how teams are now placing retrieval indices, vector stores, and lightweight extractors near data. The upside is better privacy and lower tail latency. The prerequisite is operational discipline, observability, updates, and keys managed well. Tiny agents, big responsibility. Surveillance tech, smishing to IMSI-catchers. Rogue base stations and smishing kits are proliferating globally, with police responses that vary by country. In Cambodia's scam-plagued Sihanoukville, a driver was arrested ferrying 2 SMS blasters in silver cases, one sporting a Toyota sticker that matched the Prius he drove, and a later roadblock inspected 624 cars, finding 2 more blasters and netting arrests for drugs, trafficking, and online crime. Swiss police nabbed a 52-year-old Chinese national alleged to be smishing as the post office, Migros, and UBS loyalty points scams, and later arrested 3 more tied to a West Switzerland campaign. The Bank of the Philippine Islands warned customers about a holiday surge, saying about 80% of online banking fraud cases were tied to smishing or fake apps. In Lebanon, a digital rights activist alleged Hermes series drones were flying IMSI-catchers over Beirut, hard to verify, but consistent with established drone-borne interception patterns in conflict zones. At home, the procurement pipeline for militarized policing remains opaque. A report on the U.S. 1122 program, distinct from 1033, details how local agencies purchase discounted military gear via federal buying power. 16 Lenco Bearcats, a $428,000 Star Sapphire thermal imaging system, a $1.5 million surveillance software license, and covert camera kits, among more mundane items. Average discounts near 20% help departments buy more than they might otherwise, but FOIA responses are sparse and centralized Army data is lacking. With limits loosened by recent executive action, watchdogs warn of rising risks to civil liberties, especially as some local agencies aid federal immigration raids. The connective tissue across these stories is simple. Communications infrastructure is dual use. From spoof cell sites to thermal imagers, the same networks that deliver services can be turned into attack vectors or tools of control. Security teams should assume hostile radio environments for users and adversarial procurement in their jurisdictions and build accordingly. Governance hardens, boardroom fallout. Europe quietly set the blueprint for AI governance, moving from ethics to enforceable process. Sens Pren 18286 translates Article 17 of the EU AI Act, the requirement that high-risk AI providers maintain a quality management system, into an auditable standard. Once harmonized and cited in the EU's official journal, expected late 2026, conformity to Pren 286 creates a presumption of legal compliance for that article. Unlike ISO 42001's management philosophy, this is product safety territory. Data governance and quality, risk management across the lifecycle, post-market monitoring and incident response, regulator and customer communications, and end-to-end documentation with audit trails. The reach is extraterritorial. If your system is placed on the EU market or affects EU residents, you're in scope. Early movers have about 14 months to get operational experience before enforcement bites. Inside the AI companies, governance questions are anything but abstract. In a newly surfaced deposition, Ilya Sutskever confirmed sending a 52-page memo to OpenAI's independent directors recommending Sam Altman's termination, writing that Sam exhibits a consistent pattern of lying, undermining his execs, and pitting his execs against one another. He used a disappearing email mechanism out of fear the memo would leak, included most or all of the screenshots he had, many sourced from Mira Murati, to paint a picture, and drafted a separate critical memo about Greg Brockman. Asked why he didn't send the Altman memo to Altman, he said he believed Altman would find a way to make them disappear. However one reads the motives, it underscores the stakes. Documentation, evidence chains, and board process are no longer optional in AI.